Okay, the next section is the wrapper classes for numeric types. Now, we've talked about wrapper classes, and wrapper classes are just that. They are classes that basically kind of go with some type of a primitive, so they go with a primitive data type. If we look in the book here, we can see that we have a wrapper class called byte, double, float, integer, long, short. Now notice they are classes, so the first letter is uppercase. And the byte goes with the byte, double goes with a double, float goes with a float, integer goes with an int, long goes with long, short goes with short. So again, just like a class, classes have instance variables and they have methods. So each one of these classes has its own set of instance variables and methods. So yeah, so here we have a two-string method where we have int I equals 12, double D equals that, and I can say string str1, integer two-string, and double two-string. I do have some code, well, we'll get to that in a sec. I have some code written that in these examples. We also have some other methods. We have one called two binary, two hex, and two octal strings. And what that will do is it will convert a numeric value, in this case an int, into that particular um, type of numeric data set. Okay, so binary is again just zeros and ones. Hex is it's a 16 digit numbering system, so it goes 0 through 9, then A, B, C, D, E, F, then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1E, 1F, then 20. So it's a 16 base. Then octal is an 8-digit numbering system. That means it goes 0, 1, 2, 3, 4, 5, 6, 7. And then we have 10, 11, 12, 13, 14, 15, 16, 17, 8, 17, and then 20, and it kind of goes on from there. So this will actually convert a number value to that particular item. We also have min values and max values of different um, wrapper classes. So in this case, we're using the integer, so I can say the integer.min value. Notice I didn't have to set it, instantiate anything. I can use that class just by itself, just to get a method that doesn't expect anything into it. So in this case, this particular method has a void return and has nothing in the parentheses being passed to it. So I can just say integer.min value, integer.max value. It will let me know what the max value is for that class, what the min value is for that class. This might be kind of a neat one to create, to basically see what the values are for each one of those different classes. Okay, so let's take a look at some code I've written here. So here we have a two-string method. So I basically have my int12, my double 14.95, and I say string integer.toString. So here I am. It's kind of like a parsing, so to speak. And so I'm saying integer.toString, so I'm using the toString method of the integer wrapper class, and I'm passing an I, which is an int, and I'm doing the same thing for a double.toString. I'm passing the D, which is the number pair, and then I go ahead and print those out. And it's going to print out a string value of those guys. And then I basically, here is my 2 hex, 2 binary, and 2 octal. So here's the binary. So I take, so here's a number 14. Here it is converted to a binary, to a hex, and to an octal. And then down here is the integer min max and the double min max. So let's go ahead and run that. So if we take a look at this, I do have the split example up here, which we covered just a second ago. So here it is, string 12, string 14. And again, we can't really tell that they're strings, but they truly are strings. And this guy is, the number is 14. Convert that to a binary, it's 1110. Convert it to hex, it's an E. Convert it to an octal, it's 16. Okay, so here's the min max value of an int is, what is that, negative, boop, 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 boop. It's in the billions. And same thing with the double doubles, it's probably in the quadrillions, so you get very, very large numbers there. Okay, so as you can see, that'd be kind of a nice little cheat sheet to have by your desk, printed out to kind of see what those different items are. Now, I think we've touched on autoboxing and unboxing. And what autoboxing does is it's the process to automatically box something up inside of an object. Okay, so I can take this item, whatever it is, this object, and I want to box it as this particular object. So example in the book shows we have an integer, so that's an integer class. We're going to call it my int is equal to 5. And then I say int primitive number. So the primitive number is just that. It's an integer primitive number. And I say primitive number is equal to my int. So when I say integer, my int is equal to 5, that's an auto box. I take this numeric value 5, which is a primitive number, and I'm putting it into an integer class. So that I've auto boxed it. So I've taken this integer and boxed the integer class around it. Well, then when I come over here and I say primitive number equals my int, I'm unboxing it. So I'm taking it out of this integer class, I'm boxing it and put it into a primitive value. So I've basically unboxed it. So I can take a primitive value and put it into a box, auto boxing, which is they think of as a class, the uppercase letter of that primitive. So int is integer. And then I can do just the opposite. Take it out of that box and put it into a primitive value. So auto box, unbox. Now, one thing we have to do pay close attention to, and that's the fact that there's some things we can and cannot do. For instance, we cannot do this right here where we say array list int list equals new array list. So we cannot auto box an array list with a primitive. That is basically a huge no-no. Says it right here. It says you cannot, however, store primitive values in an array list. Okay, so that we just cannot do. If we need to do that, we would basically need to do this. Array list uppercase integer, the wrapper class, list is equal to new array list integer. That is okay. We can do that. So if we do need a specific data class as far as the numeric values, make sure we use the wrapper class to basically do that. So now let's kind of take a look at this thing called the test score reader class. And so if we bring up the test score reader, so here he is. It's a plain class. It looks like it has two instance variables. So we have a scanner input file and we have a string line. Here I have a public test score reader. So again, this is my constructor. I have a string file name, and it's going to throw an IO exception if we have some type of an input output. Again, this is going to be covered, I believe, in chapter 11. We're going to cover that very slightly, but just realize it's a way to capture errors. So I've got file is equal to a new file name, and input file equals new scanner file. Okay, so I basically kind of I've set up a file and I've set up a file scanner. Okay, so again, I passed in the file name. So I read next line, throws an IO exception. There I've got a Boolean line read, and the line read equals the input value has next. So if there is another record, that gets set to either true or false. If line read, meaning there is another record behind that, I say line equals input file next line, return line read. And then I've got get average, which looks like it does a split of the tokens, and it's got a split by a comma, and it's going to put them into an array called tokens. And I say for string tokens, so again, it goes to the array tokens, each element at a time, and throws it into str. Then I say total plus equal integer parse int string. So I'm expecting integer data types there. I convert them to integer and add it to total. Then the average is the double. So here I am doing a cast of total divided by tokens.length. And then I return the average. Okay. And then I have my file close, and again it throws an IO exception if there's any type of an error, and input file.close. So here I have test averages as my void main. I've got a double. I have a integer, so average and student number, and we set it to 1. Test score reader equals a new test score reader. So again, here I'm instantiating a new test score reader. And there I have a grades.csv. So I need to have a CSV file within the folder of my workspace where the str or the the SCR folder is, and then it will be able to read that. I have a while loop while there is an X line within the reader, so we got a file reader. Average equals score reader, get average, so again it reads, and then the system out is the average for student, blah 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 blah, student number, and then it closes it, and then it says there are no more scores. Okay, so let me open up that grade CSV folder, and when we open it up, the CSV folder is basically what's called a comma delimited folder. It will I'm having an error here. Hold on. Okay. Well, it's going to fight me, so we're going to open it up a different way. So open with Notepad. There we go. So basically what a comma delimited file is, meaning that here we have a line of code with a new line at the end. So that's one record, another record, another record, another record, another record. And it's comma delimited, meaning each field is separated by a comma. Okay? So we're going to read a line, and then we're going to get the average. Remember, we did the tokenize, where it was we tokenized it into an array by comma. So if we run this guy, we can see the average for student 1, and that's remember the very first line of code. It takes all of those and averages them, and for each student, and then it basically shows no more scores. So again, let's go back over to the test score reader, and the test score reader, again, when it basically says get average, which is the name of this method, we basically have a total set to 0, we have a double average, which is not initialized yet, and then string, there's where we basically have our array, and we basically say line split. So we read that first line, and it's split by commas, and we load it into this array. So this array is for one student only. And then I say for string, again, it reads each one of those numeric values and adds it to total. And then we come back around for this for loop, and we basically read the next line basically. So we keep doing that, keep doing that, keep doing that, and then we will have a total for each and every one of those students. So pretty cool. So the tokenize into a string array, pretty slick. Okay, the very last page, which is 610, it talks about common errors to avoid, and there we have using static wrapper class method. Let me bring that up so we can actually kind of read it together here. So here we have, it says using static wrapper class methods as if they were instance methods. Many of the most useful wrapper classes method are static, and you should call them directly from the class. So again, that's why I'm able to say integer dot min underscore value, because it's static, meaning I can just use it. It's already instantiated. Try using the string comparison method, such as starts with and ends with, for case sensitive comparisons. So kind of like what we covered in the previous video lectures for the previous week. Basically use those guys to basically get some good comparisons. Thinking of ending position as a substring as part of a substring. Methods such as getChars accepts a starting and ending position. These characters are the start position, which is included in the substring. Okay, and again, we always have to remember if we don't find anything, it's -1. Extracting more tokens from the string tokenizer object is then exist. Don't try to get more than what's there. trying to extract more tokens from a string tokenized object will then exist will cause an error. So again, make sure we stay within what we basically know there. So that's the end of this particular chapter this week.